Unit 1, Lesson 15, Comparing Data Sets. And 15.1 is talking about bowling partners. It says each histogram shows the bowling scores for the last 25 games played by each person. Choose 2 of these people to join your bowling team. Explain your reasoning. So I want you to go through and look at the statistics for each of these bowlers here and decide which 2 would you choose for your team and why. So you need to give some good explanation. You need to talk about maybe the mean or median or standard deviation, IQR. You need to tell some good reasoning as to why you would choose them. Okay, so I want you to pause the video and go through and answer this. You can answer it down here at the bottom, or you can answer it beside each person that you choose, each bowler. Either is fine. So pause the video and answer this, and then whenever you finish that, you can unpause and continue on. All right, 15.2, we are comparing marathon times. So all of the marathon runners from each of the 2 different age groups have their finishing times represented in the dot plot. So you have the ages from 30 to 39 on this first dot plot, and then ages 40 to 49 on the second one. And it's wanting to know which age group tends to take longer to run the marathon, and explain your reasoning. So looking at this, it looks like the longest amount of time for the age group of 30 to 39 looks like about 380 minutes. And then it looks like the longest for this one is maybe 450 minutes. So you can tell right away that the 40 to 49 age group is the ones that would take the longest. And you could look at maybe where the median is. So if you're looking at this 30 to 39 age group, the median is going to be somewhere in the middle here. If you look at the 40 to 49 age group, the median is going to be further to the right than when compared to the 30 to 39 age group. So you can tell that the median is going to be higher for the 40 to 49 age group. All right, so looking at this, well, that's not what I want to do. Let me undo. Text box. And we can say the runners ages 40 to 49 are slower because they have a greater median. The center of the data, which would be the median, is farther to the right on this distribution. And we just talked about that. So the median is going to be further to the right. All right, which age group has more variable finish times? Explain your reasoning. So which age group, remember variable or the variation is which one is more spread out? Which one has the higher standard deviation or higher interquartile range because it's more variable. So looking at this, 30 to 39 looks like it's more scrunched together, and 40 to 49 age group is more variable. It's more spread out. So the runners ages 40 to 49 have times that are more variable because this data is more spread out along the number line than the data in the dot plot for ages 30 to 39. So we just said that age group 40 to 49, the data is more spread out than it is for the data in the age group of 30 to 39. So the 40 to 49 age group is going to have a greater IQR. So the 40 to 49 age group will have, or we could just say has, a greater IQR, interquartile range, because the middle half of the data looks more spread out. So we can look, it's just this data is more spread out. So the IQR for this is going to be larger. It's more variable. All right, so I need to see if I have room to do this little discussion here. If we can have room to place this somewhere, I guess we could probably put it right here. So this is not actually part of the Are You Ready for More? This is going to be the discussion discussing 15.2. All right, so I'm going to give you this information for these age groups. So we have ages 30 to 39, and we're just going to look at these statistics. So we have the mean is 294.5 minutes. Standard deviation, I'm just going to put SD, is 41.84 minutes. Median is 288.5 minutes. IQR, interquartile range, is 65 minutes. Q1 is 260 minutes. Q3 is 325 minutes. So these are the statistics for the age 30 to 39 age group. Now I'll give you the statistics for the 40 to 49 age group, and then we're going to look at these. So the mean is 340.6 minutes. Standard deviation is 59.93 minutes. Median, 332 minutes. IQR, 92 minutes. Q1, which is quartile 1, 289 minutes. And Q3 is 381 minutes. Okay, so looking at those statistics, what measure of center and measure of variability are most appropriate to use with the distributions? So we have those two distributions. What measure of center is going to be most appropriate with these? Remember, we use mean as a measure of center when we have a symmetric data distribution. Well, looking at these are not symmetric, so we need to use median. So let's do this. What measure of center and measure of variability are most appropriate to use with the distributions? So we have the median is the most appropriate measure of center. Or we can just say it's the most appropriate because it is closer to where the majority of the data is. And we can also say this distribution is not symmetric. Since we used the median as the measure of center, we would use the IQR as a measure of variability. Because median and IQR go together. Mean and standard deviation go together. Okay, so which points show values that are most likely to be outliers? So if you're looking at these, we would probably say the slowest runners, maybe to the right. of each of these dot plots would more than likely be outliers here. But it says based on the displayed information, so the statistics that we have, it says, are there any outliers in these data sets? So for 30 to 39 age group, the outlier would need to be greater than, and we got to calculate it, it's Q3 plus 1.5 times IQR. So we're going to say Q3 is 325 plus 1.5 times, I'm just going to write times here, or let's just do this, greater than, let me do this equation, if it'll let me. I don't think it'll let insert that equation there. Okay. We'll do this, and then we will Q3, which was 325, so it needs to be greater than that. 325 plus 1.5 times, and our IQR is 65. So I'm going to calculate that real quick. So remember, order of operations, you would do 1.5 times 65. Oops, 1.5 times 65, and then you would add 325 to that. So it needs to be greater than 425. 422.5. So looking at 30 to 39 age group, the largest value looks like 380. So no, there would not be any outliers for that one. So let's look at the 40 to 49 age group. The outlier would need to be greater than, I'll have to move this down a little bit. And equation, let's do greater than Q3, 381 plus 1.5 times our IQR is 92. So let's calculate that. 1.5 times 92 plus 381, and we get 519. So it needs to be greater than 519. So let's look. The largest value is at 450, so no, they're technically, going by that formula, there are not any outliers. Make sure I did that. 381 plus 1.5 times 92. Okay, so based on the formulas for outliers, there would not be any outliers for each group of runners. Okay, all right, let's go on to 15.3, and we have these data sets, and they want us to, for each group, we're going to determine the best measure of center and measure variability to use based on the shape of the distribution, and then we're going to determine which set has the greatest measure of center, which one has the greatest measure of variability. So let's look at 1A and 1B. Both of these are symmetric. So we have a bimodal distribution, and then we have a bell-shaped distribution, but they are both symmetric distributions. So we could say both are symmetric. So we would use measure of center, mean would be the best measure of center. If we use mean as a measure of center, then we would use standard deviation best measure of, let's do this, of variability. Okay, and so I'm going to move this up so that it's just describing 1A and 1B. We can make this a little smaller maybe. Okay, so that would go for that one. We also need to tell which is the greatest. So looking at these, which one has the greatest measure of center and which one has the greatest measure of variability? Well, the measure of center for this first one would be -8. And the measure of center for this one would be -10. Because remember, when it's a symmetric data set, the mean and the median are equal. So distribution 1A would have the greatest measure of center because -8 is larger than -10. It's closer to 0. And then, so 1A, let's put this on this side. 1A has the greatest, or we'll say greater measure of center. And looking at which one has the greater standard deviation or greater measure of variability. You're looking at which one has more data away from the center. So that would also be 1A because most of the data is to the outside and not the middle. And the greater measure of variability, since the data is farther away from the mean, or we could say the middle in this case because the mean and the median are both the same. All right, looking at 2A and 2B. Both of these data sets are also symmetric. So again, we would use mean as our measure of center. If we use mean as a measure of center, we're going to use standard deviation as a measure of variability. Both are symmetric. Mean would be the best measure of center, and standard deviation would be the best measure of variability. And then we've got to determine which one has the greater measure of center and which one has the greater measure of variability. So let's look. Our mean for this one would be 20. So it'd be right here in between 19 and 21, so it'd be 20. And then our mean for this one would be 30, right in between 29 and 31. So 2B has a greater measure of center. But looking at the variability, you look at which one has the data that's more spread out, and that would be 2A because the data is more spread out for 2A. 2A has a greater measure of variability because the data is more spread out. Because the data is more spread out. You could say that. Or you could say that it's farther away from the mean. Either would be fine. Okay, looking at 3A and 3B, these are not symmetric. So since these are not symmetric, we want to use median as a measure of center because you have these values that are further out to the left, and you have some values maybe that are further out to the right from the middle. And so, you know, these are a little bit skewed, not a lot, but they're just a little bit skewed. And so that would affect your mean more than your median. So you want to use median as your measure of center. So median would be the best measure of center since the data is not symmetric. So if we use median, then we want to use IQR for our variability because those go together. You need median in order to find IQR because you have to have median, and then after you find median, you find Q1 and Q3, and then you subtract Q1 and Q3 to get your IQR. IQR would be the best measure of variability. And again, it's because they are not symmetric. Okay? And then we've got to determine which one has a greater median, which one has a greater variability. Okay, so looking at where the center probably is, the largest number for 3B is 5.5. Well, the center of this data distribution, 3A, is probably going to be larger than 5.5. So that tells me that the median for 3A is going to be larger. So 3A has a greater measure or greater median since the center is to the right of the center for distribution B, 3B. Okay, so variability, which one looks like it is more spread out? So 3A appears to be more spread out, so 3A also is going to have a greater variability. So you say because the data is more spread out. Let me see if I can scoot this up just a little bit so we can see it. Okay. All right, looking at 4A and 4B. These are both symmetric. We have a bell shape and a uniform. So both of them are symmetric. So remember, symmetric data distributions, we're going to use mean is the best measure of center. And then standard deviation is the best measure of variability since the distributions are symmetric. Okay, looking at which one has a greater measure of center and variability. So this measure of center would be 100. That's not what I meant to do. I meant to do the highlight 100, and then this measure of center would be 1, 2, 3, 4, 5, 6, 7, 8. So it would be this 90. So the measure, so 4A has a greater mean. Now what about the variability? Which one has a greater standard deviation? Well, for A, we can see most of the data is clustered in the middle, and then it starts spreading out to the sides. But for B, it's all even. So we don't have a bigger cluster of data in the center, so therefore 4B is going to be considered to be more spread out. So 4A has a greater mean, and 4B has a greater standard deviation, which is variability. Okay, So we can see the data in 4A is more spread out, and then, the data in 4B is more spread out. The data in 4A is more clustered together, so it's going to have a greater standard deviation. Okay, looking at 5A and 5B, these you cannot tell really if they're symmetric. They're not symmetric. They would be even on each side if they were. Also, we cannot calculate the mean, so therefore we cannot use the mean as a measure of center here because this is a box plot and we can't figure out the mean for the box plot. So we would use median is the best measure of center. And if we use median, then we're going to use IQR is the best measure of variability. And we can say, because they are not symmetric. You can also say because they are box plots and we can easily see the median and calculate the IQR using those. Okay, so now we've got to see which one has a greater median. So this median is 500. This median is 700. So 5A has a greater median. Okay, for IQR, we're going to do 900 minus 600, so that's 300. On this one, it looks like that's 7, so we'll say 650 minus 450, so that's 200. So 5A also is going to have the greater interquartile range, IQR. So 5A has a greater median and a greater IQR. Because we calculated those IQRs, we did Q3 minus Q1, so we did 900 minus 600, we got 300, and then we did 650 minus 450, and we got 200. So we could tell that 5A had a greater IQR. All right, looking at 6A and 6B, we have a political podcast has mostly reviews that either love the podcast or hate it. 6B, a cooking podcast has reviews that neither hate nor love the podcast. Okay, so probably 6B, the data is going to be more in the center because they're saying that they neither love nor hate it, so they're in between. 6A, they either love or hate it, so there's no in between, so the data is going to be more on the outside. So for these, we could just simply say that we don't know if they're symmetric or not, so we're just going to determine on these which one would have a greater variability. So 6A would have a greater variability since the values will be concentrated more on the ends of the distribution because they either love or hate, so there's not much in the middle. Okay, looking at 7A, stress testing concrete from site A has all 12 samples break at 450 pounds per square inch. Stress testing concrete from site B has samples break every 10 psi starting at 450 until the last core is broken at 560. Stress testing concrete from site C has 6 samples break at 430 and the other 6 break at 460. So for these are going to be all 3 symmetric data distributions. So we would use, these are all symmetric, so we would use mean as a measure of center, and standard deviation as a measure of variability. Okay, as far as which one has a greater, the mean for site A is going to be 450 because they're all the same. Site B starts at 450 because the least value for site B is going to be the mean of site A. So we know the mean for site B is larger, and the mean for site C is going to be at 445 because we have 6 samples break at 430 and then 6 break at 460. So if we add 430 and 460 together and then divide by 2, we get 445. So the mean for 7C is going to be 445. So 7B is going to have the greater mean. As far as variability, since site A, they're all the same, so they're going to have a standard deviation of 0. Site C is all going to be within 15 psi from the mean because the mean is 445. 430 is the minimum, so that's within 15. 460 is the maximum, so that's going to be within 15. And then looking at 7B, it's going from 450 all the way to 560. So that one is going to have also the greater variability. So 7B has a greater mean and standard deviation. And so in the explanation, this one is a little bit sometimes difficult to visualize what's going on here. So, but we've discussed why it has a greater mean and why it has a standard deviation. So I'm not going to type all that out. Let's see. All right, so right here, let's look at the summary. To compare the data sets, you look at the measures of center. We're going to look at the measures of center and the measures of variability. It tells you the shape of the distribution can help choose the most useful measure of center and measure of variability. So how do we figure that out? We look at the shape, and that will help us. Okay, when distributions are symmetric, so this is important, or approximately symmetric, the mean is going to be the preferred measure of center. And then if you use the mean, you're going to pair it with standard deviation as the preferred measure of variability. When the distributions are skewed or when outliers are present, the median is usually a better measure of center, and you pair that with IQR, interquartile range, as the preferred measure of variability. So this whole paragraph is important. You need to know this. You need to be able to understand this, be able to explain it. We have a test that will be coming up soon, and so you need to be able to demonstrate how to choose the appropriate measure of center, the appropriate measure of variability, and why. And this paragraph helps you with that. All right. And then it just goes on to give you some examples. So you can read through that and highlight anything else that you think is important. And how you, let's see if it talks about that. You can either calculate the measure of center, mean and median, and then, or compare them, and then you also have your measures of variability. You look at how spread out the data is, so you compare those. The data set with the higher measure of variability is more variable, which means it's more spread out. Okay, why is the mean the preferred measure of center for symmetric distributions? Because the mean takes into account every individual piece of data. And so it more accurately represents that data set, the center. Why is median the preferred measure of center for skewed distributions? It's because remember when we plugged in different numbers to find the statistics, when we added in outliers, a lot of times our median did not even change, or maybe it changed by one position. Median is where is the center of the data, position-wise. So if I add one outlier that's 1,000 times compared to the rest of the data, then it's only still going to change that over the median over one number. So it's not going to mess up the data as much as it's not going to mess up the measure of center, the median, as much as it would mess up with the mean. And so sometimes outliers could be mistakes. So we don't want it to mess up your statistics if it's not even a very good representation of the data, because it's an outlier. It could be a mistake. It may not be a mistake, but we want to use the median for those skewed distributions. Okay, so again, read through these examples. You can always pause, you can rewind, go back and listen to something again, or retype something if you need to, and then go back and complete the cool down for this lesson. If you have any questions, reach out to me, send me a message, email, or you can ask me when I return.